Okay, so let's look at C. Similar problem, and it's a trigonometric function. We are not afraid of trigonometric functions. We know how to handle them. Okay, so we'll just go through the same process, and especially at this point, what we're doing is relying on the calculator to get us the value. We just want to make sure that we can write the correct and equivalent expression using the limit of the Riemann sum. Okay, so again, uh, if you tried this one on your own, you can check your answer in the answer key. If you need some assistance, please come back and view this video. All right, so delta x is going to equal pi minus 0, b minus a, so the top minus the bottom. So delta x is just pi. All right, our x sub k's are going to be the left endpoint, which is 0, plus delta x, which is pi, times k. So x sub k is just pi k. All right, our f of x sub k is sine of pi k. All right, which if your math senses are tingling, they should be, um, because what we know is that k is an integer. So we're talking about integer multiples of um, pi, right? K is going to be 1, so that's 1 pi. K is going to be 2, that's 2 pi. K is going to be 3, 3 pi, right? And then so forth, so on. There's something happening there, right? We're looking at sine of pi, then sine of 2 pi, then sine of 3 pi, sine of 4 pi, and so forth, so on. So let's see what we think is going to happen. But we're doing this just from 0 to pi. All right. But anyway, we'll see what it comes out to be. What we want to do is write the correct limit expression. So we can say this is the limit as n approaches infinity. Okay, again, n is the number of rectangles, right? We're pushing that towards infinity, and our delta x is pi, and we want to look at the sum of k, 4k equals 1 to n of sine of pi k. Oh, let me go back. I missed something. I think I got a little too excited. My delta x is not just pi, it's pi over n. Okay. So let's see. What else is that going to change? So this is going to be pi over nk. All right. And so then we get sine of pi over n times k. All right, well, that's not quite as simple as it seemed just a second ago. So delta x is pi over n, right? And then here we're looking at sine of pi over um, n times k, or pi k over n. Okay, all right. I'm glad I caught that mistake. And yes, this is a little more complex for us to figure out, but we've got our calculators, so let's see what they tell us. All right, first we'll do the integral to see what we should expect. So we're going to go to math. We're going to go to number 9. Okay, we're integrating from 0 to pi. I'm going to use the pi key, or the pi value that's already in the calculator. I'm not going to do 3.14. I want all the bits and pieces. All right, and then we got sine of x, and we're doing this with respect to x. All right. Okay, so when we do that, we get 2, right? Something nice and simple. All right, now let's see about what we came up with as the equivalent limit of the Riemann sum. And so I'll go to y equals, okay, I'm going to have pi over n, or for n, I'm using x here. So we got pi divided by x. Okay, I'm doing the summation for k equals 1 to n. And I'm going to delete all of this. I just want to do sine of pi k over n. We'll divide by x, okay? If you haven't already, make sure you check your mode for your calculator. We want to be in radian mode, all right, since we're dealing with the sine function. And so we'll do y of, let's just jump to 1,000 rectangles and see what we get. All right, when we do, we get 1.99. All right, so we're very close to 2. So we can see that we have correctly come up with an equivalent expression.